Good morning to all. Now, this is in continuation with the series on problems of Fourier series. Let us start with. Now, in continuation with the previous one, there is another waveform which is repeatedly asking like this. Look at, there is look at this waveform follows like this. Find Fourier series of this one. This is equal to for minus t, here minus 2t, 0, t, 2t, 3t, 4t, here it is 5t, like that. Now just look at between minus 2 to minus t, the same wave is being repeated. It is periodic. Now here the signal, it is passing through the origin. In the previous case, just like the amplitude equal to A, here the amplitude equal to minus A. This is the question given in university examinations. Now just look at how to make it. Same way, here just like how to get the equation minus t minus A here below the axis coordinates, here t, A, uppercase coordinates. The equation of the straight line that passes through the origin equal to y minus y1. In the case of y, we use x of t, y minus y1. Let it be x1, y1. Let it be x2, y2. Now, y minus y1, that means what? Y minus y1 is equal to y2 minus y1, a minus plus by x2 minus x1, t minus of minus t plus t into, in case of x minus x1, this becomes plus t. Now this implies x of t e plus a is equal to 2a by 2t. 2 cancel, this becomes a by t into small t plus t. Now this implies x of t is equal, x of t plus a equal to, multiply this, a by t, t plus a. This a cancels. Therefore, x of t is equal to a by t into t. Now, this is the equation of the first one. Not in the previous case. In the previous case, there was no extension. The graph wave is above the axis. Here, the wave is above as well as the below the axis. Therefore, this is symmetric about the origin. This is symmetric about the origin. All symmetric waves are odd. It is symmetric. Therefore, it is symmetric. It is symmetric wave. Therefore, symmetric wave means what? Therefore, it is odd signal. So for odd signal, we know that A naught equal to 0, Bn equal to, A naught equal to 0, An equal to 0, but not Bn. That means Bn is not equal to 0. Therefore, in the given Fourier series equation, A naught, it contains no An, it contains only Bn. Therefore, for the given signal, x of t is equal to summation n equal to 1 to infinity Bn into sine n omega naught t only. This is the main. Now here we will find what is Bn. Now here, what is Bn? Bn equal to 1 by t integral. What is the period? Given period. Given period is minus t to t. The given period here, t belongs to which one? Minus t to t. Therefore, this is from minus t to t. What is x of t? A t by t. That is a by t into t into sine n omega naught t dt. X of t into sine n omega naught t. Now this will become, now look at taking constants out of this integral, a by t square minus t to t, t sine n omega naught t dt. Now just look at here in this case. Now in this case, t is odd signal individually. Sine signal is odd individually. Odd into odd becomes even. Therefore, here it can become as, the integral can be written as 2a by t square integral 0 to t into sine n omega naught t dt. Now, this becomes 2a by t square by using uv method, that is u into, for sine the integral is cos n omega naught t by n omega naught minus integral. Keep this term as it is there, this minus that minus will become plus, and it will become cos n omega naught t by n omega naught into differentiation of t equal to 1 with respect to t. This becomes 0 to t. Now this is equal to 2a by t square constant minus 1 by n omega naught, the remaining all t into cos n omega naught t plus integrating cos sine n omega naught t by already one constant is there, therefore n square omega naught square between the limits 0 to t. Now this will become 2a by t square minus 1 by n omega naught t, substituting t into cos n omega naught t plus sine n omega naught t by n square omega naught square. Now just become, here again we have to substitute 2a by t square into minus 1 by n omega naught, substituting omega naught equal to 2 pi by t. Therefore this become 2 into cos 2n pi plus, now here sine 2n pi by n square omega naught square by into between the limits 0 to t. Again omega naught equal to how much? 2 pi by t. So this will become 2a by t square into minus 2 pi by t. This will become t by 2n pi into cos 2n pi value equal to 1. This becomes t plus sin 2n pi 0. Now this will become, just look at the t into t numerator t square, this t square gets cancelled, 2 gets cancelled, this will become minus a by 2n pi. This is the second equation. So we got, what value we got? Bn. Therefore substituting this value in the main equation, that is equal to x of t equal to summation n equal to 1 to infinity, its value minus a by 2n pi into sine n omega naught t. The summation is for n, remaining all are constants. Now here, because of symmetricity, it is odd, no a naught, no a n. So this is equal to minus a by 2 pi into summation n equal to 1 to infinity into sine n omega naught t by n. This is the output of this signal. The output of this signal, just look at how we got. Here one important point, just we have to make it, whenever the wave is passing through the origin in this way, diagonal way, in the full format, then only we have to say that it is a symmetric wave. All symmetric waves are odd waves. That's why whenever we use the word odd, automatically a naught will become 0, an will become 0. We are supposed to calculate only the value of bn. That's why the main equation will be reducing into a single term. Here we got bn. In almost all the calculation, there is a common substitution that is called omega naught equal to 2 pi by t, sin 2n pi equal to 1, cos 2n pi equal, sin 2n pi equal to 0, cos 2n pi equal to 1. These are the common substitutions in every problem. Here at last what we got? Bn value we got 2. Substituting this value in the given equation, the equation we got. because the summation is for n, remaining all are constants. Keeping all the constants out of the summation, that is the output, that is the given signal. This is the signal. In the previous case, just look at, there is no graph below the time axis, but here there is a graph above and below. This is called symmetricity. But if the graph is like this, it is not symmetricity. You have to calculate all the values a0, an, bn. In this case, we can say it is odd. In examinations, the most of the cases, generally odd waves will be given because for your time, or otherwise it takes more time. So most of the waves are just like odd waves. Only odd wave examples will be given. Thank you.